Hi, this is Mrs. Smith. Are you ready to go over Newton's second law of motion using the equation force equals mass times acceleration? Okay, now from our flashcards, we know the way Newton's law is applied is that if you try to push a car and you try to push a bus, it's going to take more force to push the bus and less force to push the car. I think most of you get that. That makes sense. Let's look at it a couple of different ways. Now, if we have the same object, the more force, the more acceleration. So let's say we have a major league pitcher throwing the ball and a baby throwing the ball. It makes sense to you that more force, he's going to have a lot greater acceleration on the ball. Okay, now we have the same force applied to two different objects. So the smaller mass is going to have a large acceleration, and then that large mass with that same force is going to have a small acceleration. So I think that makes sense to most of you. So whenever you get to your problems, just keep that in your mind to make sure that the answers you're choosing are reasonable. So the masses of four vehicles and the net forces acting on them as they enter a highway are recorded in the data table. So all these are different masses. Now they all have the same force. Which vehicle has the greatest acceleration as it enters a highway? So from what we talked about earlier, I know that if it's the same force, less mass is going to accelerate more, so that leaves me with the coupe. Answer choice B. That makes sense to me. Now, if I wanted to prove it with the mass, I can have force equals mass times acceleration, and that's the beauty of math and science. They work together. That math will prove to me this science concept. So let's do some math, and I'm going to show you. So, 4 students race toy cars on a track. The mass and the acceleration of each car is recorded in the data table below. So now I see the masses are all different. So the accelerations are different. So that means the forces are different. They didn't all do the same force. Okay, which toy car had the greatest applied force? Okay, so just from my gut feeling, what we talked about, the greatest force is usually needed for the most mass. But then I also know that the greater force, if the mass is the same, it's going, acceleration. So I'm torn between these choices, but just from reasonableness. But so now let's work it out. Okay. Whenever we're doing the math problems in science, I want you to guess it out. So the given, I'm going to start with car 3. So let me highlight that for you. Now in car 3, the mass is given. The mass is 0.25. The acceleration is given. The acceleration is 1.5. The unknown is the greatest applied force. That's my unknown. So I'm going to stop right here for a second. Watching some of you work out problems on the quiz on Friday, some of you were confused here. Whenever I say given and unknown, that means from the equation here. It's going to be, these are your options. So some of you are putting like given is a toy car. No, that's not in the equation. Or the unknown, which toy car. And that's true, that's unknown, but from this equation is what I'm talking about. So after you have the equation, then you're going to substitute numbers in. So F is unknown, so I need to bring that down. Equals, my mass is given, so I'm going to substitute that number in from the given, times my acceleration is given, so I'm going to substitute that number in from the given. Now to solve it, force equals, now I like to set it up like this. There's different ways for you to multiply. So whichever way works for you, go for it, as long as you get the right answer. But I set mine up this way. Now, the reason I chose to work this problem versus this problem is so that we can have that extra practice with those decimals. A lot of you were struggling with that on the test. And let me do that instead of that highlighter. Okay, so you don't have to line these decimals up when you're multiplying. That's whenever you're adding. A lot of you were confused on that part. So when I multiply, I'm going to ignore those decimals. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Then 1 times 5 is 5. 1 times 2 is 2. Then I'm going to add these together. 5 plus 0 is 5. 5 plus 2 is 7. 2 plus 1 is 3. Now, multiplying with a decimal, I'm going to count 1, 2, 3 digits behind the decimal point in the problem. So my answer has to have 1, 2, 3 digits behind the decimal point in the answer. So I solved it. F equals 0.375 newtons. So this was number 3. I'm going to write that here. And bear with me, I'm writing with a mouse instead of a real pen. I'm going to make me another little column right here for my forces. Okay, so, but we're not finished, so don't stop. That gets some of you with a multi-step problem. You stop too soon. Now don't be lazy. I know it's a lot of work, but don't give up. Keep going. We need to do the other ones because which toy car is the greatest force? How do I know if I only do one? All right. So let's see if what my gut was telling me was right. Next, I'm going to do car 4. Okay. So given to me for car 4 is still the mass. This time the mass is 0.21. The acceleration is 2.5. My unknown is still the force. My equation is the same. I'm going to substitute my numbers in. I don't know F, it's unknown. So F equals, I'm going to substitute my given mass times my given acceleration, substituting it. Now I'm going to solve. Force equals mass 0.21 times acceleration 2.5 5 times 1 is 5. 5 times 2 is 10. 2 times 1 is 2. 2 times 2 is 4. Uh-oh. I'm seeing a difference right here already. 5. 2 plus 0 is 2. 4 plus 1 is 5. 1, 2, 3 digits behind the decimal point in my problem. So I need 1, 2, 3 digits behind the decimal point in my answer. And look, my first thought was wrong. Car 4 is 0.5. 2. Writing with this mouse. 0.525. So right now I can eliminate 3. I'm going with 4 now. I think 4 is the correct answer. But I need you to still work these out. That's your homework. So work these 2 out and then give me the final answer here. Now I worked 2 out for you. If you need help, go back and refer to it. Until next time, may the mass times acceleration be with you. You get it? May the force be with you.